When I was small, I read a book that talked about a train path through the center of the Earth that's going to shorten my trip to the other side of the world. And you see science fiction movies and novels where people talk about going down to the deep Earth. So it's just impossible to get down to some deep Earth. And in fact, the deepest hole we've drilled so far, and it's a small hole, is about 12 kilometers depth. And that's less than 1% of the Earth's depth. We do use a non-invasive technique. We have seismic waves traveling through the Earth, carrying information about the interior of the Earth recorded by stations around the world. The investigation of the Earth interior from a seismological point of view started as soon as the seismometers were invented. We found out that the Earth is like an onion. We have different layers starting from the crust, which we are standing upon. Beneath that, we have the mantle, and beneath that, we have liquid outer core, and beneath that outer core, we have the solid inner core. Earthquake signatures have information about how they were generated, as well as the material that they travel through. We have a slinky here, which is used to demonstrate the different types of seismic waves that propagate through the Earth interior. If we take the slinky apart, we can first generate the compressional waves. The compressional waves are the type of energy that propagates through the material as compression and dilatation. So if I push on one end, you can see that there's something that goes from this end to that end and comes back. So that's the compressional wave that travels through both the liquids and solids, and that's the P wave. Now, we can also move the end in sideways direction. And you can also see that wave moving from this end to that end in sideways manner. And that's the shear waves that travels through the solid. But within the liquid, if you move on one end, there's nothing that would stop, that would make it come back to its original position. And that's why shear waves do not travel through liquids. S waves travel through the mantle directly from earthquake to the station. Now, if the compressional wave hits the core mantle boundary, some of it goes through and travels through the core and comes out on the other side of the world, but some of them gets bounced back. And we do have energy coming back from the bounced waves as well as the waves that travel through the core. And when we look at them from different stations, we can infer things like the depth of the core mantle boundary. Now, S waves are also very useful. We have the S wave arrivals recorded at stations, and that tells us that the mantle is solid. But because the outer core is liquid, we don't have any recordings of S waves from the waves that should have gone through the core, and that's one way of telling what the state it is. So the mantle is solid, outer core is liquid. We know that immediately from having S waves in the mantle and no S waves from the core. All of these are recorded at stations as ground motions, and we are taking all that information from various phases or seismic waves traveling through the Earth to decipher the image of the Earth interior.